Okay, so on the review, I'm going to go through every single one of these questions real quick. Some of them I'll spend more time on than others, but again, you need to know the names and how to name each one of these shapes. So on the first part, you're naming it based off of just being given the net. So on here, this net, you have triangles for most of the sides, right? So when the lateral faces are all triangles, what type of shape does that have to be? Pyramid. So this has to be a pyramid. Now, what type of pyramid? You only have one base for a pyramid. So what's the other shape? So you could say a square or a rectangle. You could name it by a couple different things. Now, here, I only gave one possible option. So it would have to be a rectangular pyramid. But if this was a free response question, you could call it a rectangular pyramid. You could call it a square pyramid. You could call it I don't know. You could use a rhombus as a base. You could do a lot of crazy things. A parallelogram as a base. But again, if it's free response, there's more options. But square or rectangular pyramid works. Number 2. On this one, now this is no longer a pyramid, right? Because we don't have a bunch of triangles. We don't have a single triangle here. It's a prism. We have a bunch of rectangles. So since we have a bunch of rectangles, this is going to be a prism because all the lateral faces are rectangles. And then the two bases have to be the same. They're both pentagons. So we name it based off the bases. This is a pentagonal prism. So, all right. Number 3. This one gives you faces and edges and asks you to find vertices. This is based on Euler's law, which is F plus V equals E plus 2. Again, there's multiple ways that you could state this formula. I don't care how you remember it. I wrote it on the board 2 different ways. In Springboard, they taught it this way in Springboard, and then in the answer key, they used it the other way. So I don't care which way you use it. It's all the same. But F plus V equals E plus 2 is the way that we learned it in class. So faces, they gave us faces. That's 25. They gave us edges. That's 36. We're looking for vertices. And we don't have to plug anything in for 2, so it's just 2. On here, simplify. This is now 38. This side, we still have the 25. Subtract off the 25, and you're left with 13. So our answer is we have 13 vertices. All right. Good so far? You could have something like that on the test. Yes. What is the name of the geometric solid below? Triangular prism, yeah. All the other sides are rectangles except for 2 of them. So those are our 2 bases. This is a triangular prism. I saw a hand go up. No? Nothing? All right. On number 5. So let's draw the cone first. So on here, so, could we have a circle? Yeah, if we go parallel to the base, our cross-section would be a circle. Can we have a line? Yes, if you had a plane that intersected this entire side but was tangent to the circle, it would make a line. Can we have an oval or an ellipse? Yes. That would be if we had a plane diagonal, it would make an oval. I got rid of it, but you guys might remember that from class. A point. Can we have a point? Yes. If we had a parallel plane that was sitting right on the very top of the cone, just like that, it would only touch the tip, and it would be a point. Could you have a square? No. Could you have a trapezoid? No. Could you have a triangle? How? Cut it in half. So vertically, cut it in half, straight through the vertex, it would be a triangle. All right? So all those things. So it doesn't really help very much on this figure, but let me show you with my example here, right? So we got this. If I just go in order here, a circle, if I cut it parallel to the base, of course I pick up a Sharpie that doesn't work here. Let me get one of these edges. Expo marker, whatever. I went parallel to the base. Again, not the best drawing, but it makes a circle, right? Then if we went, let's say at an angle, hard to do, but if we went on an angle, I know, I'm going to come closer. There. So, you see the circle going that way? That one is more of an oval, right? Yes? Alright. What other ones are we missing? A point, that one, again, just picture my hand. If I touch it like this, it's only touching the very tip, so it's a point. If I had it right on the edge, it's only intersecting it at a line. If I had it, what else? If I cut right down the middle, so let's erase these other things, and we went straight down, both sides, straight across the bottom. It's going to make a triangle, right? Okay. So, again, those are our general shapes that we have for this one. Now, okay, on the next part of this, we got number 6. Both of these, if rotated around the parts given to us, they would be what? Cones. So this one would look kind of like this. This one will look more like this. Alright? Now, they're both cones. So, we got a cone and a cone. What's different about them? Well, if you look at their measurements, the radius, the height, and the slant height, we can look at some more similarities and differences here, because for this cone, the radius would only be what? 3. For this one, the radius would be 4. For this one, the height is 4. On this one, the height is
3.
What would be the slant height on either of these? 5, because we have a 3, 4, 5 triangle, so we got the slant height. Now, other things that you could include on this. You could say, instead of just saying cone, you could say that they're both right cones. You could talk about, again, the radius and height were opposites. You could talk about the way that these are facing. This one's facing with the vertex point up. This one's facing with the vertex point to the left. Again, anytime you are asked to compare and contrast anything, it's not only things that are different, but also things that are similar about them. Yeah.
Wait, there's one of those oblique cones.
Huh?
Like messed up cones. You know how there's
An oblique cone? I could throw an oblique cone on there. I probably wouldn't do that with a
You
rotation.
don't have to.
Again. Yeah, that's a good question. Was there an oblique figure on here at all? No, there is one oblique figure on the test. I can picture right now. I can throw one on there for tomorrow. But I think all it was identify it. I don't think it was like anything special. It's just like a tilted cylinder or a tilted pyramid or a tilted cone, or it's obvious that it's not going to be right. So you should know oblique as a vocabulary. How many questions? I think it's only 14.
That's not good. Are you serious?
Yeah. Again, there's you need to show your work. Again, can you receive partial credit for a question? Yeah. So again, make sure you show all your work. On number 7. If a polyhedron has 7 faces, what is it called? Heptahedron. Again, that prefix means 7. Now again, that one won't be on your test. This next one, again, I wouldn't ask it like this, but I could ask you how many faces. Right? So how many faces are there? So we have 5 faces. How did you know there's 5 faces? Yeah, use Euler's law again. F plus V equals E plus 2. So vertices was 9, edges was 12, and we don't know what the faces are. So we have 14. Subtract 9, you get 5. So we have 5 faces. That's a pentahedron. Again, I wouldn't ask you that part of it. I could ask you how many faces, though. So 5 faces. I could also ask you on some of these, Now, I don't think either one's on this paper, 3 or 8 do this good, but if I gave you something that worked out as a prism or a pyramid, I could ask you to identify the prism or the pyramid as well. Because again, that was in Springboard, that whole section where we had the prisms and pyramids, that they had identify it based on the faces, edges, and vertices. All right, on 9. To the nearest square inch, what is the surface area of the prism below? So looking at this prism, there's more than one way that you can do this. You have to decide what to use as your base and what to use as your height. So I would choose to use the base that's on the bottom, but remember, for a rectangular prism, it's the only shape that we have out of all these shapes where we could choose different parts to be our base and still come out with the correct answer. Because our definition of base is that we have two sides parallel and congruent. Well, in a rectangular prism, all sides are rectangles, so it doesn't matter what sides you call the lateral faces. And then you have 3 sets of parallel congruent sides. So on here, I'm choosing to use that as the base. So if that's the base, I can find the base area by doing 10 times 3, which is 30. I can find the perimeter of the base, which is 10 plus 10 plus 3 plus 3 is 26. We have the height, then would be 7. Now, if you chose a different side, your numbers might look different. But once you plug these into your formula, you should get the same answer. So our formula for surface area of a rectangular prism, surface area equals 2 times base area plus perimeter of the base times the height of the solid. So we have 2 times the base area was 30. We have the perimeter was 26. We have the height is 7. 2 times 30 is 60. 26 times 7. Hold on. 6 times 7 is 42. 182. Yeah, okay. Yeah. So 182 would be our value. And then add that up and we get 242. And again, our answer should be in inches squared. Do not forget your units. Do not forget your units. Again, anything that you have it as an area should be in units squared. Anything that you have that's just a single dimensional measurement, like radius, height, perimeter, circumference, all those things are in just plain units. Yes?
Are you going to take off like a point or something?
Yeah.
Just at 1 point?
Is Cavaliers going to be on the test?
It'll be on the next test. Yeah. Yeah. Yeah, we and Ms. Oswald were just talking about that the other day. Yeah. No, that will be on the next test. On one of the work, I think it was on one of the worksheets she did. It had Cavalier's principle on it, but it's something to do with volume, so it'll be on the next test. It was just on one of the worksheets she had, so she went over it. All right, on number 10, to the nearest hundredth of a square inch, what is the surface area of a cylinder with a height of 8 inches and a diameter of 6 inches? So this is a cylinder. Now, our formula for surface area of a cylinder, you can either do it as 2 times the base area plus circumference times height, or you could actually plug it all in, which, again, since it's always going to be a circle for your base, you can always plug into this one. So 2 pi r squared plus 2 pi r h. So I'm going to just plug into that formula because we're given the height, right? The height is 8. We're given the diameter, which will easily tell us the radius, is 3. Those are the only 2 values that we need for this entire equation. So just plug them in and simplify. 2 pi 3 squared plus 2 pi times 3 times 8. Simplify it. 2 times 3 squared. Well, 3 squared is 9. 9 times 2 is 18. I would wait to do the pi till the end. Huh? The 2 in front of the 18. That was my equal sign. I dragged my pen when I go. No, that's all right. All right. 2. Sorry, I thought it was something else with that one. 2 pi times 3 times 8. So on here, 2 times 3 is 6. 6 times 8 is 48. 48 pi. Add those two together.
It's 60.
66.
66 pi. Now, if you plug in 3.14, since it says
207.
round to the nearest, 207.24.
I got 214.
Now,
Inches squared.
inches squared. Yeah, don't want to forget our units. Again, if it tells you to round, then you're plugging in for pi, right? If it tells you to leave it in terms of pi, then you're leaving it in terms of pi. All right, everybody good on that side? All right, let me grab a new sheet, and we'll do the back. All right, on number 11. The surface area of the cylinder below is 60 pi, centimeters squared. The radius is 3. They want to know what is the height of the cylinder. Yeah, it is up on the board. I'm going to do it again since I'm recording it though. All right, so on here, again, we're using the same formula that we just used in the last problem. We have surface area equals 2 pi r squared plus 2 pi r h. Now, unlike on the last problem where I wrote it out in the simpler version, I wouldn't write this out in the simpler version because we can't solve for more than one variable at a time. So we need to solve for the height on this problem. So I'm going to use this formula, plug in for all the other pieces. We have 60 pi goes in for surface area. We have for the radius, it's going to be 3. So 3 squared plus 2 pi 3 times h. Now, since every single term on here has pi as part of it, we can go ahead and get rid of pi. So pi can cancel out on every single one of these. It's kind of like a GCF back in algebra. If you had a GCF in every single term, you could divide it off, and you still get the same answer, right? So here, same thing. Pi is in every single term on both sides of our problem. So you can divide off pi, it goes away. Now that we divided it off, we just have 60 equals 3 squared is 9. 9 times 2 is 18. 2 times 3 is 6. Hold on. Oh, go ahead.
Cancel it off because it's on both sides, right?
It's on every single term on both sides of the equation. Yeah.
Thank you.
Yep. So now, if it was just on every term on one side of the equation, then you couldn't cancel it off. Right? Now, if it, say there was a problem like this where they didn't give us our answer in terms of pi, but we had pi's over here, you could divide everything by pi, but when you divided the other side, you'd have to actually divide by 3.14. Like so,
I get it.
to further your question that you asked, yes, pi was on both sides, so that allowed us to do it. Say this side was not in terms of pi, but we still had the pi's over here. I could divide off the pi's over here, but when I do that, I'd have to divide the one that wasn't in terms of pi by 3.14. So you could cancel it off that way. All right. Now, the 18 we can go ahead and get rid of by subtracting it. So that gives us, not 50, 42 equals 6h. So divide by 6, and our h is 7. Now, that answer is in what type of units?
Oh, it's
Is it just centimeters or centimeters squared? What is it?
no, just centimeters.
Just centimeters. Again, it's a single dimensional measurement, a distance, so it's just going to be 7 centimeters. On number 12, all right, this one there's a lot of questions on. So this one uses our formula because we have a regular hexagon. It uses our formula for a regular polygon back from the other section. So when you get down here to part B, you're going to have to use your area formula as either 1/2 ASN or 1/2 AP. All right. Now, in order to do that, remember, in a hexagon, if you draw in from the center of the hexagon, say these two lines, you would make an equilateral triangle. So they told us that this part's 4. So we could say this part's 4. If you were to draw in the height of that triangle, you're actually drawing in the apothem of that figure. And when you do so, this becomes a 30, 60, 90. So half of this was 2. This is the short leg of my 30, 60, 90. So the long leg is going to be 2 radical 3 for my apothem. So that's my apothem. A equals 2 radical 3.
Is there going to be something like that on the test?
Where you have to use the apothem? Yes. Now, where you have to find the apothem, I can't remember. Is there a 30, 60, 90 triangle on the test? I believe there was. So whether it's in this problem or not, you do have to use the 30, 60, 90 triangle. There is a problem where you have to do apothem. I can't remember if I put in the same problem or if I split it into 2 different ones. But you do have to have a problem like this where you use the apothem, and you have to do a problem where you're using a 30, 60, 90 triangle.
So basically, you just took the one of the sides and then divided by 2.
Mm-hmm.
You get the other side. But how do you know if the other part is with them?
This part, again, the part I drew in pink, that triangle was an equilateral triangle. Again, that's something that was always true anytime we had a regular hexagon. Right? So again, something simple. This will always work for a regular hexagon. If you do half of your side, you get this piece. And then this piece will be that part times radical 3. So your apothem of a regular hexagon will always be one of your sides divided by 2 times radical 3. Again, if you want to remember it that way, it works. All right, let's do the rest of this problem. So lateral area of the prism. I saw lots of people doing this different ways. I saw a lot of people, as I was coming around, doing one of the rectangles and multiplying it by 6. That's fine. That works. All right. Again, I'm just using the formula. So let me write the whole formula down real quick. Surface area equals 2 times base area plus perimeter times height. If I'm finding the lateral area, I normally just use perimeter times height. So the perimeter of this, all the way around the figure, 4 times 6 is 24. The height of this figure would be the length of BC, which is given to us. It's 6. So all I have to do for this part is lateral area equals P times H. So 24 times 6, which is 144. Again, if you were to do it the other way, you essentially do the exact same work. So if you were to take the area of one of these rectangles, you'd have 6 by 4, which again is 24. Then 24 times 6 is again 144. It works either way. I just had most of the people when I went around talk me through it, and they just use one of the rectangles. It's the same work.
I was going to ask, for the lateral area, would the unit be like cm squared or something?
cm. Oh, for lateral area, yes. This will be in centimeters squared because it's area. On the next one, this one, again, we're plugging in. We already found the apothem. We know the length of one side. We know the number of sides. We even know the perimeter. So you could use either format. If you chose to do the first one, you'd have 1/2 ASN. So apothem is 2 radical 3. S is 4. N is, there's 6 sides. Now, if you chose to do the second formula, you'd have almost the exact same thing. It's just these two numbers are already multiplied together. Again, it'd be my next step in doing it the first way. Now, no matter which way you do it, the 1/2 and the 2 can cancel off. All right? So, half of 2 is just 1. So those can cancel off. So now we have 24 times radical 3. If we wanted an exact value, that'd be it. But it doesn't ask us for an exact value. It's as round to the nearest hundredth. So it wants us to round. So we're going to have to multiply that out. And 24 times the square root of 3 is 41.57. All right? What do you mean? Yeah. Sorry, I didn't say my units yet. I was asking you guys if my number was good because my number's good. All right. So I make mistakes too. So I was asking you if that was good. I was waiting for a response. Sorry. It is area, so it's in centimeters squared. All right. Now, total surface area. Well, we have lateral area. We have our base area. So our formula for a prism, again, 2 times base area plus, yep, I just rewrote my formula. You didn't miss anything. So I just rewrote my formula I had written up at the top. Now, we don't have to do perimeter times height all over again. We already did that. But we do have to make sure we multiply this value by 2. Now, we would have 41.57 plus, what was the other one? 144. So 2 times 41.57 plus 144 is 227.14. And this is, again, in units squared. Again, every single one of those answers was area, so they are all in units squared. Most common mistake on that type of problem is forgetting to double your base. On number 13, we have a pyramid. They tell us that it is a square pyramid, so we know that that base is a square. They tell us that AU is 10. Well, if AU is 10, that means all these sides are 10. Now, they also tell us that SQ is 12. Our formula for surface area of a pyramid is our base area plus 1/2 PL. So we have to find our slant height, which is right here. And I draw my apothem to complete a right triangle. So if that's 10, this would be 5. 5, 12, 13 makes a Pythagorean triple. Alright, where did I lose you?
When you started drawing the triangle thing, I understand 5, 12, 13, but like...
So I drew this piece that I drew in, I'm drawing in my slant height. It goes from vertex perpendicular to one of my sides. That's my slant height. Right? So I got my slant height, I got my height, and then the distance between those would complete a right triangle. And we can actually call that our apothem in this problem.
The distance between the height to the slant height?
Yeah, that is 5. And we know it's 5 because this whole distance is 10.
Okay.
So that same distance would be the same across the middle as well, right?
Oh, because that's the apothem.
So if that's 10, this has to be half of it, so that would be 5. So now that we had 5 and 12, we took 5, 12. You could use Pythagorean theorem if you want to. But again, you should know that triple, 5, 12, 13. Again, that's one of the triples that comes up all the time. Now, other things that you need to know, you needed perimeter for this problem. Well, 10 is on every single one of these sides. 10, 10, 10, and 10 is. And then base area, also pretty easy. It's a square, so 10 by 10 is. So we have base area, we have the perimeter, we have the slant height. Plug them all in. So we have 100 plus 1/2, 40 times 13. So 100 plus 1/2 of 40 is 20. 20 times 13 is 260. 260 plus 100 is, and again, this is area, so this is feet squared. Yeah, it said they're in feet, so feet squared. And that would be our answer. All right, on to the next one. Number 14, a cone. Now, they didn't draw a cone here. If you want to draw a cone, it might help you. All right, let's see what they gave us, though. A cone has a slant height of 10, a radius of 6. What is the surface area of a cone? Well, let's write out the formula first and see if we need anything. Surface area equals our base area plus, you could say this many different ways, 1/2 our circumference times our height. Or, the way I prefer writing this, again, if we plug in our formulas for a circle, this would be pi r squared plus pi r l.
Wait, I thought it was CL. Yeah, I thought it was CL.
Oh, whoops, thank you. I did make one typo there.
Yeah, that's what you told me when you told me.
Oh, wait a minute.
Sorry.
That's alright.
Yeah, I told you H as well. My bad. That should be slant height. For any one of our slanted figures, it should be slant height for area. So for a cone or for a pyramid, we should be using slant height, which is what I wrote in the second version of the formula. All right. Anyway, so I like this one because it already has everything we need. We have our radius, we have our slant height, and those are the two things that they gave us. So we don't even have to draw our figure if we don't want to. Again, on a lot of problems, if we need to find something extra, draw your figure. This one, we can just plug right in. So we have pi, plugging in our radius of 6, 6 squared, plus pi, plugging in our radius, 6 squared, sorry, not squared, sorry, didn't mean to square that. Radius is 6 times our slant height of 10. So, 6 squared is 6 times 10 is 36 plus 60.
96.
They want this in terms of pi, so we don't have to change anything. That's our answer. This is also in feet, so we would want to say feet squared for the final answer. On number 18. I saw that 18. Number 15. The cone below has a height of 24. So let's label this picture. That's 24. The diameter is 18. So this whole distance across is 18. So nearest hundredth of a square foot, what is the lateral area of the cone? So first thing we need is the radius. Radius is going to be 9. We also need the slant height when doing a cone. So we need to figure out this piece here. So we can use Pythagorean theorem because 9, 24 is not part of a triple. So we're going to have to use Pythagorean theorem. So we have, it's going to come out to something bad. So let's see. We're finding our slant height. So slant height squared equals 9 squared plus 24 squared. The 9 squared, oops, my calculation turned off. 9 squared plus 24 squared is 657. So then if we square root those, it comes out to a big decimal. 25.63. I'm going to go out an extra decimal place for right now, just because the more decimal places you go out before the end of the problem, the more accurate it'll end up being for your final answer. So the next value after that 2 was a 0. So if I stop there, it's pretty good. So on this problem, now that we got our slant height, we can go ahead and plug into our formula for lateral area. Now, we don't need the entire surface area formula. So up here, we have the entire surface area formula. You just need the lateral area. So pi RL. So lateral area equals pi RL. So we're going to plug into that. Pi, the radius is 9. The slant height was what we just had. And if you want your value to be more exact, at this point, we haven't changed anything, so you should still probably have that value in your calculator. So just take the last value you had in the calculator and multiply it out with the other two values. So times 9 times 3.14, which is what it told us to use, would be 724.36. 724.36. And this is in feet squared. Again, only did lateral area for that one. This one? The one above? Hold on, let me see. I think they had a question on this one. Well, you got a question on this one? Yeah.
Why is it 9%?
That's 9 times from up here. The slant height that we just found. 25.632 was our slant height. One second. I think I had a teacher just text me. Give me a second. No, I'm not looking at that right now. All right. So, you said you had a question on the one above. This one, right? 14?
So, you know the first equation has the 1 half used, like, what happens to for the second one?
So, if you were to plug this in, the circumference formula is actually 2 pi r, right? So here we only have pi r because the 2 and the 1 half cancel each other out.
Okay.
Yeah, good question. All right. On number 16, What is the surface area of a sphere with a radius of 6 inches? So again, they gave us the radius. That's all we need. Our surface area formula for a sphere is 4 pi r squared. So 4 pi, our radius was 6, so 6 squared. 6 squared is 36. 36 times 4 is 144, isn't it? No. Did I do that right?
Wait,
No, I don't think I did that right. Yeah, 144.
Wait.
I
think so.
Yeah.
Oh, no, you said.
We just did that in class there, remember the whole long division thing?
Yeah. All right. So we got that. Now it said round to nearest hundredth. So even though we have a nice exact answer here in terms of pi, since it's saying round to nearest hundredth, they don't want it in terms of pi. So we're going to plug in 3.14. So 144. Oops, I just typed that wrong. 144 times 3.14 is 452.16, and this would be in inches squared. Yeah, and on any test, I will always tell you to use that. The reason why I always tell you to use that is because on most standardized tests, they're not going to say use the pi button on the calculator. They're going to say use 3.14. Usually on like an SAT, it's usually at the very beginning in the directions, like at the very beginning of a test, it'll say use 3.14. On the FSA, they normally say in every question with the problems, they'll say use 3.14 for pi. They hardly ever do that one. I used to see it like back when we did FCAT a long time ago. If you can picture their reference sheet that they use for like every level of FCAT, it used to say on there use either 3.14 or 22/7. But that's the only. Yeah, I haven't done FCAT in a long time. I think the last time they did that was. My first 2 years teaching, so 9 years ago was the last time they used FCAT, I think. So you guys would have been in kindergarten, I think, or first grade. Oh, they might have used a version of FCAT for lower grade levels, but for high school it was gone by then. Yeah, because we had FCAT, but then we had the EOC, and now we have the FSA EOC. So it's, yeah. All right, last two questions. Yep. So yeah, 22/7, probably not going to use it very often. Number 17. What is the surface area of the hemisphere in terms of pi with a diameter of 10 meters? So, yeah, so on here, if we're talking surface area of a hemisphere, we have surface area equals 3 pi r squared. So this is of a hemisphere, right? For a sphere is 4. This is half. But now you got to remember, when we do a hemisphere, it's not exactly half of the sphere for surface area because you have half of the area, but then you add the base, which is another circle, so you have to add one more circle back. So it's 3 pi r squared. So, yeah, for a hemisphere, you got to be careful because, now, if it was just asking for the lateral area of a hemisphere, it's 2 pi r squared. So, on here, we have the diameter was 10. The radius would then be 5. So plug it in. 3 pi 5 squared. 3 pi 25. 25 times 3 is 75 pi. That's our answer. Right there, B. It was in meters squared. Now, on 18. 18 is actually a really easy question. So, we have surface area of a sphere, which is 4 pi r squared. But, what did they give us to plug in?
314.
They gave us this. 314, that's what though?
That's pi.
That's this is our area of a circle. right? Normally, a lot of people would look at this question and be like, oh, I got to find my radius first. You don't have to find your radius first because pi r squared is my area. So this is my area. So you just plug it in. So we have 4 times 314, which gives us 1,256, which is D. All right. Again, some of your questions are going to be harder. Again, some of your questions will be harder. Some of them are going to be easier. It depends on the question. Again, the one thing that's not on here, which I said at the very beginning of tutoring, questions that involve, there weren't any word problems on here. There's I think 2 word problems on the test. Again, you have to know your formulas for surface area. You have to know your formulas for area. You have to be able to do lateral area of any one of the figures. You have to know Euler's law formula. You have to know your special right triangles. You have to know Pythagorean theorem. Pythagorean triples is a good thing to know. You have to know all the vocab. There's a lot of things that you have to have memorized for this test. And don't forget, for the next test, you still have to know all those area formulas because you use them in volume as well. Question?
How do you find the?
I thought you just have to know the
find the
volume.
lateral area of a hemisphere, but how do you find the lateral area of a sphere?
All right, let me stop this recording and I'll answer your question.